All right, well, I think it's about time that we get started. For those of you who know Barry and Moore, you'll notice that he's not in the room, and that was the original schedule for today. But we have instead Nobel laureate Nov02 Ojima. I'm not sure if Barry is on the list with IPCC as the other Nobel laureate, but we sort of built this schedule realizing that sometimes things fall apart, and kind of hoping that Dennis would have a chance to address the seminar series. And so this was in a pinch, sort of what became it. Dennis is a longtime member. I don't think I have to really introduce him to this crowd, but I think he's been here since his PhD at CSU back in the 80s, and going on to do a lot with respect to carbon modeling, especially in grasslands. That's been in the U.S. as well as Mongolia, all over the world, and a recognized expert for that work with Sentry and Descent, the inner comparisons that were done in the 90s with that. And I think an interesting thing for Dennis is now, well, it's very interesting for me that he's university PI or director for the North Central Climate Science Center, but that he's transitioned to the human dimensions component of that research. And so having kind of seen things unfold the way they were, as well as in addition to that carbon cycle monitoring, working with the Millennium Ecosystem Assessment work at the Heinz Center, kind of realizing, to use Dennis's phrase, the difficult or the hard, soft science of working with humans and bringing this into human dimensions. So I think it's just really interesting to think of someone with a career that spanned as long and as much as Dennis has, especially in the quantitative modeling side of climate change and carbon, evolving into the human dimension, kind of brings a lot of credence to that point and the importance of that issue. So without further ado, let me let Dennis take it over and tell you more about this kind of thing.
Thanks, Jeff. Yeah, I must add, it's a real pleasure to work with Jeff at the North Central Climate Science Center, and actually to have this opportunity to step in for Barry and talk a little bit about some of the directions that we're going and looking at some of the challenges dealing with climate change in our region. But in addition, sort of pushing the research framework to really encompass the human dimension side of things. Because as Jeff alluded to, I've been at this work for 3 decades, and have been really, first just comfortable and satisfied with my ecosystem research. But as I saw the challenges and the emerging issues around the world, and the need to actually come up with solutions and not being satisfied with just looking at the ecosystem side of the equation, that it was really important to engage and actually understand how to engage with and conduct social science research. And I'm not a social scientist. I had a compliment last week in Montana by being addressed by a social scientist who said that I was the most unusual ecologist because of the way that I was framing the work that we're doing and really engaging a lot of the concepts and frameworks that the social science community deals with. The outline I'll give you today will sort of rely some of my biophysical backgrounds. I'll start with some of the iconic figures. I'll go very quickly over some of the global change issues and data observations that we have around the world, and then go into what are some of the consequences that we're seeing both globally and regionally in the Western United States, and then use a water resource example about how we actually are looking at trying to look at the societal needs and the framework of looking at adaptation strategies or coping strategies in our region on these water issues. This is pretty iconic. We've seen the ocean and land temperatures globally increase, especially over the last 20 years, and in particular, the 5 warmest years have been 2010, 2005, 1998, and so on. And so we see in the data records of our observations, this continuing increase of temperatures across the globe. In addition, we understand with the buildup of carbon dioxide and other greenhouse gases that this is contributing to the warming around the globe. What's alarming to us is that the decadal rates of increases of CO2 in the atmosphere is growing increasingly, and this is despite the greatest efforts of improved efficiencies of fossil emissions and reductions in some of the deforestation around the world. But despite that, because of the growing economies that we have, that we're actually seeing these continued increases in CO2 in the atmosphere as well as other greenhouse gases. Associated with that, is really the role that fossil fuel emissions play into the growth of that carbon dioxide in the atmosphere. And we're seeing that with the set of emission scenarios that we've used in the past. This is sort of the envelope of emissions, and this one that we call the A1F1 was the most fossil fuel aggressive emissions. And when we started using these emission scenarios back in 2000, we thought that this was the worst case scenario. That there's no way, given the political will, sort of, and the technological advances that we were putting in place, that we start reducing our emissions, and that there was no way that we would even come close. But as you see by the observations of our atmospheric concentrations and the sort of the emissions that we have, that we've been tracking that worst case scenario pretty closely. And in fact, in 2011, we see that our emissions have even advanced even more quickly, and the rate increased up to 3.2%. So we're not doing, as a society, though the message out there, we have not been doing a very good case in preventing the rate of our emissions to the atmosphere. So what does that mean around the world? And this is just a snapshot that Noah put together. For this kind of last month, we're seeing fires in the West. We're seeing dry conditions through the central part of the United States. We're seeing hurricanes, and we saw that in a very strong situation just last week. And we're seeing these increased thunderstorms. So we're seeing increases in a more agitated atmosphere, which is being reflected into these extreme events across the globe, really, of these events that are really affecting, in the way of natural disasters, more places around the world and more cost to society. Jim Hansen really put together a nice paper earlier this year to sort of document what does the more agitated, warmer atmosphere mean, in a way of looking at the decadal looks of that, in a way of how is that shifting the norm, and looking at the probabilities of these extreme events, especially in the summertime hot temperatures. So you see quite dramatically this progression of curves as it moves to the right, and this is the last decade, 2001 to 2011. And you're seeing then here in these sort of description of the distributions, how that shifted, and then especially for our summer temperature anomalies that we're really seeing more exposure to these high temperatures across the globe. This particular picture is extremely troubling, because this is the September minima that we saw this year. And prior to this, 2007 was the least ice over the Arctic for thousands of years. And you see, if you were quick, you could actually circumnavigate the pole. So the Northwest Passage is open, and the ramifications of this is quite interesting and somewhat uncertain. What this indicates is that as new ice forms, that it will be thinner as it grows in the winter, which then allows greater recedence during the summer next year or subsequent years. So the vulnerability of the polar ice caps, the Arctic ice cap, is much more sensitive now to warming. The albedo that is being experienced experienced here then tends to become more absorptive because of the change in albedo, and so the heating of the Arctic Ocean is intensified, again leading to a more accelerated loss of the ice sheet. The manner in which that gets manifested in the northern hemisphere climate is something of great concern. The jet streams that circulate out of here and out of the Arctic vortex is really important. What we're seeing in this last storm was that because of the change of this vortex, we actually saw a high pressure system hang up right here. And so if you were watching Sandy last weekend, you saw the projection of it moving out toward the northeast into the northern Atlantic, but then on Sunday it took that left veer back toward the west into the northeast coast. That trajectory change was due by that high pressure area that was setting up here. What we're also seeing, because of this change in the energy balance in the Arctic, was that there was a low pressure zone also staying up here, which caused a huge cold front to move through. The conjunctions of those two then really caused enhanced the damage that we saw on the East Coast. So these type of changes in the jet stream out of the pole, not only at this time of year and then into the winter, is really puzzling and concerning, because it's going to change the way that we have experienced through the fall and winter seasons. The winter last year that we saw the Arctic jet come down over northern Europe in February and March is being looked at as part of that change in the wind streams and jet streams in that area. So there's a lot of uncertainty. A lot of new research is going on, and I've been looking into this because it's very troubling as we look at a world without this being ice-free. And as the previous graph indicated, by 2050, at the rate of emissions that we're seeing, this will be completely ice-free under certain projections. So keep an eye on that. It's really concerning, I think, to see this happen. And so again, just to give you a better sense of this, this is sort of these are from the various model runs that people have been doing. This is the standard deviations around the mean. You can see we're far outside that. And so the projections that we're seeing is that we're going beyond what we have incorporated within our climate model. So the past IPCC reports have been quite conservative to this type of event. Again, just looking at observations around the United States, we're seeing that in our region, the north central region, we're seeing quite a bit of warming. It's 2 to 3 degrees warming Fahrenheit over the century. We're seeing reflections of this in the precipitation and drought patterns across the United States. Again, over the western half of the United States, we're seeing quite a bit of observed drought. In our mountainous regions, and this is the Grinnell Glacier, that's really iconic for Glacier National Park. You see it receding very, very rapidly. We've seen that throughout the Rocky Mountain chain and the rest of the western United States. Snow cover is also being, in the northern hemisphere, being reduced. This is the snow extent in June, and so we're seeing that the amount of snow carrying over in the season is becoming less and less. This is becoming less and less. So that you'll have, we're seeing snow fall, snow cover being impacted, and that's due to the spring thaw and having that come 2 to 3 weeks earlier. So a number of impacts on our biophysical and environmental systems throughout the West, or throughout the nation, throughout the West. And a lot of that has an impact on water. Now, that's why I sort of picked water as an example to look at these interactions and how some of the societal needs, especially in the West, we should be concerned about that as we look at these climate change impacts. In part of that, sort of water result, these downward trends are spring flow indications where they've been lower stream flow from various gauges. You see that on the Platte River, we're seeing losses. On the Kansas River, we're seeing declines. But on the other larger reaches, and especially in eastern reaches of the Missouri River Basin, we're seeing increased flow. In particular, with recent precipitation patterns that we're seeing up in North Dakota and eastern Montana, we're seeing more frequent storm events occurring relating increased flooding in that region of the nation. Then a nice slide that Jill put together. Jill Barron, as part of her USGS work with the Western Mountain Initiative, really started looking at, sort of these are a nice summary slide of increased temperatures, earlier snowmelt, reduced snowpack, evapotranspiration drought occurring. And that is one thing we haven't talked much about, and it varies by spatially where this happens. You have more intensive rainfall events that results in flooding because the environmental system can't handle as much rainfall falling at one time, and so erosion and runoff and flooding occurs more readily. What are some of these impacts? In our various ecosystems, we're changing our vulnerabilities because of these multiple stresses. We've seen plant-animal systems changing, water use and water qualities being impacted. We've seen soil properties be affected, because of evaporative losses, change in salinity. We've seen organic matter and soil fertility being changed because of changes in moisture, soil moisture and temperature conditions. We've seen expansions of weeds, pests, and diseases in various communities. And then the plant-animal interactions, they are being modified because of the seasonality and technology changes that are experienced. So taking those type of consequences and trying to pull them into a societal context, it's really, looking at the system where these type of factors are interwoven, and that we're looking at the sort of interactions between the biophysical, the socioeconomic, specific processes. So not just identifying the bits and pieces, but really understanding how those bits and pieces operate together in a more integrated system. And looking at sort of the nature of our development in the West or any part of the world is really looking at these competing and convergent demands on ecosystem services, how our livelihood component or strategies are changing, and how do we actually work at reconciling those in a way that is more sustainable, or at least that we can maintain the, for quote a better word, the well-being of the ecosystems or the environment as well as society. Part of the challenge is that we're really working in this transition of emerging complexity, where, as Jeff really highlights, the issue of stationarity being dead, that the biophysical system is changing rapidly around us, especially as we look at climate. But then, if you look at habitat and other ecosystem processes, we're seeing those change and parts of them being disrupted. But then, our social systems change rapidly as well. I guess if you're as old as I am, you can have seen a half century worth of changes in the way that technology, the way that we farm, the way that we manage water, the way that the economy and the global markets impact how we actually consume or use natural resources. So the whole complexity has to be looked at through a social lens as well as an ecological lens. And that's really important. As it comes to water, that becomes even more critical, because not only do our ecosystem use water, but as we look at energy production, food production, and just for our own well-being, our health, water is so central. So there's all these other nonlinear chaotic impacts occurring, and so we have to understand how those play off each other, looking at multiple factors, working in concert, temperature, precipitation changes in the seasonality in the way of time and space, changes in things like nitrogen or ozone deposition affecting our socio-ecological systems. And then developing adaptive strategies that both, in some cases, ameliorate the situations, but then may also be a constraint on how we meet various management goals. So I'm going to go quickly through this example, try and blend the issues of water, land, and ecosystems, energy systems. And a lot of this actually has come from the work that Shannon and I did in the recent Great Plains technical report for the National Climate Assessment. And so sort of glean some of these ideas and figures from that synthesis work. As we look into the future, we're looking at increased drought conditions, especially in the West, which results in various potential conflicts in water supply. So especially in the Southwest, we're seeing market drought stresses, and then front range. You can imagine the type of we're seeing evidence of competition for water, and how this might then play out across the region is something that will be a political problem or issue in the coming years. In particular, as we look at the Missouri River Basin, and so this is a nice graph to really encapsulate, sort of the region that Jeff and I will try to study over the next few years. Is sort of our north central region, going from Colorado, Kansas, all the way up to the Canadian border. The Missouri River Basin really intersects it quite well, and looking at, so the water supply, the Rocky Mountains, where it all starts, the headwaters of these major rivers that eventually flows into the Gulf of Mexico. But the characteristics of the Missouri, in way of looking at, the number of reservoirs that have been incorporated there in the storage capacity, the type of water volume which flows out of these dams, and these 6 dams are among the largest in the United States. But I think the other economic issue in our region is that we have over 25 thermoelectric power plants and additional hydroelectric plants that generate tremendous amounts of power for our region that's being sold into the Ohio Valley and other industrial parts of the United States. These coal-fired plants that we have in the region use water as well. And so some of the issues that we're really concerned with that emerged out of our Great Plains report was, as temperatures warm and the water temperatures warm, the cooling effectiveness of the water supply that these thermal plants utilize becomes constrained or impacted, and so that they have to actually use more water to cool them. And so the issue of how much the accessibility of water, and how do we keep those reservoirs full to support the power industry is a concern that a number of people are looking at from Department of Interior, Army Corps engineers. Much of this management is done by the Army Corps, and they're trying their best to work within their prescriptions. But part of the problem is that the prescriptions. And so as we look at climate change and working at managing for change, that how do we actually develop management practices that are not so rigid, that we actually incorporate adaptive management practices in a way that works and is suitable for the system. And so that's a discussion that is being done at various levels, and NOAA has been very effective in trying to pull parties together, look at the Missouri River Basin management, and we're involved with a number on the climate change side of looking at some of the climate change impacts with the Missouri River Basin boards. Another major feature in our system that really is important to the economic livelihood of our region is the Ogallala. The Ogallala is an extensive deep aquifer that underlies the Great Plains. And as you see the extraction or the decline in the storage over the last, I'm trying to remember the time period. I can't recall over what time period this is, but it's a dramatic drop in the Ogallala, especially in the southern part of the aquifer. In the southern part of the aquifer, there's very low recharge, and so you're seeing irrigated swamplands being abandoned, going into dryland areas, Texas and Oklahoma. The recharge area is really this area in Nebraska, the Sandhills. And so actually, the folks, it's interesting when you talk about irrigation and water impacts in the Great Plains, the ranchers or the farmers in Texas are really concerned because the energy cost of pulling water from hundreds of feet down is becoming expensive. So they're dropping out of the irrigated systems. The guys in Nebraska don't really care. They're sitting on such a huge water supply because the recharge is so readily available through the sandlands that they have in the Sandhills that they're not worried about their water supply. They have infinite water supply as they see things. So it's really interesting that you talk about the same issue in different places. In the Great Plains, you get different responses. I think I've covered that. So as we look at our societal needs, what are the basic needs that individuals have and households have within the various communities? Balancing issues of protecting ecosystems and seeing how conservation of these ecosystem services are very important. Looking at the provisioning aspects of looking at energy and food production for urban communities is really important. And then you see this increased competition between sort of urban or developed areas of the region to the extensive use of water for food production and also for energy production. And looking at the sourcing of food and production for the growing population centers in our region, how do we actually look at technology to provide clean industries so that they are more efficient at using water and they produce water or recycle the water so that what they return back to the system is usable to downstream users. And then sort of as we look at our energy mix throughout the region, how do we develop these in a way that balances constraints on water availability and the seasonality of water availability to demands that we have different times of the year for heating in the winter and then for cooling in the summer. So looking at those type of energy demands as well as production will be an important set of issues that we look at or need to look at across our region. Then as we look at sort of water management challenges, we're looking at certain uncertainties, and we see that we've been facing that already with droughts impacting stream flows, changes in the snow melt runoff, and then also looking at different areas of the region where flooding and high rainfall are impacting our infrastructure in places like North Dakota and eastern Montana. So these type of uncertainties are emerging and will continue to be a challenge as we look both at water management as well as just other societal activities within the region. Looking at mechanisms to share water and define common interests through participatory methods will be very important. Looking at how different communities value the water and its various uses. And I think these last 2 points of looking at how do we co-develop knowledge in a way that provides greater, responsibility or ownership of the issues so that solutions can be created, and that sort of leads to better governing of water for better ways of development within our region. So these are sort of some of the guidelines that a number of groups have looked at in the way of looking at water systems, and these are practices that the EU Commission has put together, as well as the Western Governor has a similar list of issues. As we look then at sort of our adaptation strategies, it's really looking at how do we take and utilize our thinking about adaptation into a more integrated framework in managing these natural resources and looking at societal needs, and developing a way that we incorporate our knowledge of uncertainty and use that knowledge of uncertainty in making or incorporating that within our decision making. And that leads to having more flexible strategies. So breaking away from the prescriptions that Army Corps may have on how much water we need to release under certain conditions, but be able to use some of the new forecasting methods and techniques that we have, and be able to use those and being more flexible on managing the water resources in the Missouri. Also realizing, and this is another graph I stole from Jill, or modified from Jill, looking at these trade-offs of our various livelihoods, from our ecosystems, conservation, looking at ranching, looking at wildlife, and what have you, and really, in this particular framework, think about how water interconnects these different livelihood strategies and ecosystem services, and that how water then is sort of a commodity that's being competed among those different needs. So as we look at this, and this is the graph that Billy Turner and co-authors put together in the Proceedings National Academy of Sciences back in 2003, where he really started identifying and trying to articulate how we actually look at vulnerability to climate change, and understanding those vulnerabilities within a social ecological context where the human and ecosystem conditions are incorporated, and then leading toward action, a way of looking at coping strategies, adaptation strategies within the context of that social ecological system. As we look inside those boxes, then we see that social and human capital as part of the social ecological system is really important, and our ecosystem services are embedded in what he calls natural capital and biophysical endowment. So these components of soil, water, and climate are part of that framework of understanding those components of the socio-ecological system. The challenge is how are those being utilized? What's the exchange of those? What are the processes which connect them? That's where the harder science of this complex system really is more difficult than the physical climate science that has been traditionally done looking at climate change. So looking at those issues of looking at exposures from the social and global environmental systems, how they change, and how these components are being experiencing changes in drivers, and then how are we moving toward different coping strategies. I put this up in that many of us are struggling how to define adaptive capacity. So this is a generic or a very useful definition of adaptive capacity, a way of looking at what are the property of a system to adjust in order to expand its coping range. You know, it's a very fine, it's a very good definition, but you really, you know, what does it mean? How do you? And that to me is the challenge of, you know, how do we, you know, what is it? What are we talking about here? What properties? How do we actually envision this system expanding to cope with these range of changing conditions? So that's where I come back to the social and natural capital, and come back to the challenge of actually understanding how they're interconnected in ways that provide, you know, sort of the change in properties. And so I think, you know, if you really want a challenging career, it's really start looking at how do we understand and unpack the property of a system to adjust, and looking at those processes that enable systems to change. And so on the social side, we're thinking of, you know, what are the institutional structures? What's the social network? What's the human capital? What do you know? What does your community know to solve a problem? On the ecological side, like, you know, how much soil fertility? What's your water holding capacity? What's your, you know, what is it, you know, what's your carrying capacity of your ecosystem for different needs? Be it wildlife, be it food production, or corn production, biofuels. Incorporating those in a way of mechanisms within your institutions about how do you then commoditize? How do you sell those things? How do you use them in the economic market so that livelihoods can be maintained? So it's looking at that interactions in the social ecological system of how the societies utilize them and incorporates biophysical with the social needs. And so that very elegant definition of adaptive capacity is useful, but then, like many elegant definitions, the devil's in the details, and how we actually look at the context of where we work and what problem we're solving is really getting into the nuts and bolts of the property of the system. Not just ticking off what the elements are, what the components are, but what are those processes of the interaction between social ecological systems. And, you know, it's something that Shannon and I have been talking about. These box and arrow diagrams are great because they describe sort of key components. What I find interesting is then getting into more nuanced understanding what these arrows mean. And so I think that's where the challenge becomes, where we start identifying, you know, at least how we need to look at different elements of social ecological systems. And then as we work through various case studies, we actually need to get into what are the processes that link it. What are those arrows? So this is a little bit better than that. The definition of adaptive capacity, or if we had another definition of vulnerability, this sort of encapsulates both those concepts of vulnerabilities and adaptive capacity and adaptation. But I think one of the things that as we try to work with management entities, it's really getting into the nut of what are they doing because they're the ones who are actually living day by day in those arrows. Their livelihoods are those arrows of managing the system. As researchers, then, how do we actually take these concepts and theories and translate this to say, how do they manage these systems in a way that's meaningful to them and translates to them? And that's something that we're attempting to do within the Climate Science Center. Actually, as a plug for a course that I think we're going to be teaching next spring, Shannon and I are going to do ECOL 592, sort of titled Managing the Social Ecosystem, or some variant of that title. So it's close to what my title was today. But basically, we're going to actually go through some case studies and actually define these arrows, really tear these arrows apart, and look at how we might better understand. I think this is my second to last slide anyway. Although the last slide before my thank you is my quote.
Arrows.
Oh, no. Okay. Yeah, so these are decision points, and those are really critical. I just sort of talked about those. But let me just wrap up by saying, I guess there's two more slides after this. That, our aim for adaptation is really, in the climate change world, that we're looking at management options which are climate informed. We may not be using climate scenarios directly in these management decisions, but we might use storylines about persistence of droughts or changes in heat waves. Really working across scales from local to regional needs, building on federal to state interactions. And I think the example of the natural hazard interactions between FEMA and the federal government to state and city governments this last week really showed that sort of interconnection of dependencies and how things should work in a way of enabling actions at the local scale with federal assistance. And sort of looking at those institutional relationships are really important, especially looking at these multi-scale relationships of ecosystem services to various sectors in our region. I've already said that. I'm trying to get to my quote. This is from the Western Governors, where they indicate, that they're seeing the frontier, that the frontier is past. That actually, as we look at development in the region, that's so rich with natural resources, from coal, from natural gas, from water, from wood, people and their intellect, that we're challenged, and we're going to be looking at a different future. How do we do that in a way that, especially with water, we do in a prudent way? That's our challenge, and it's going to be a big challenge. So, with that, thank you. The Revamp Climate is our North Central Climate Center Consortium URL. So you can find these presentations there. Other questions? Yes, Jill.
So you mentioned early on that water is a huge energy. The energy sector is a large consumer of water. And then you had a statement about thermal power generation. And you find that as coal-fired power plants. As we switch from coal to natural gas for just economic reasons, homeland security reasons, and also climate change, so we use less water? And has anyone done that kind of trade-off of different energy consumption of water and what would be the most reasonable for the system?
I don't know the answer, but Shannon might. But I know that other people do know that answer. My my guess would be that natural gas powered plants would use less water.
The couple of studies, the neighborhood study looked at some of these issues, although they were more looking at the use of water by coal generation.
Yep.
And Peter Flick focuses on, I think, the trade-off of energy and SEI, I think, too, and some of the issues. But for the region, I don't think anybody's done North Central region.
Including biomass.
Right. Yeah, there's a lot of, because it's so, the differences, variability across geographical areas is really big, and so it's really hard to apply a lot of these general studies to a specific region, because there's certain specifics in the North Central region, and even between the Great Plains and Mountain our region, it's, you know, you have pretty big differences. So I think it's a huge, really important.
For many of the biofuels, water is a big constraint, and most of the traditional, crop biomass sources would not do well in our region. Algae is one case where, because they could recycle the water, may be a case where it might be cost effective.
As you get into thinking about adaptation, look at this, you know, I'm sure you are, the system approach, how much water, how much land, yeah,
In the type of integrated analysis that we're trying to put together, then life cycle analysis and sort of end to end is really going to be important to look at those trade-offs, especially related to water.
Part of the problem is it's so hard to get data from the private sector. I mean, that's a huge issue, a huge limitation. And I know from the work I did in the Illinois Basin, the energy industry came in with their studies, and a lot of their information black box, how they got it, and, you know, so you kind of have to question if it's actually solid, rigorous data, or how much, special interest. So it's one of the many challenges.
Yeah, Tony?
If we getting back to your last, kind of question that you posed to the group, sort of these society-wide. I think the natural tendency of people, social organizations, social units is to sort of focus on different scales of adaptation. I think one way that we can approach sort of meeting these challenges is to acknowledge that there are multiple scales at which adaptation and change are occurring, and I think the nexus between the social and natural sciences that we can sort of think about the mechanisms by which resources are accessed, appropriated, absorbed, and applied to manage change. So, in ecological systems you have trophic cascades and all those kinds of things. In social systems there are institution and organizational ways in which resources are captured, appropriated, and absorbed. And some of them are sort of functions of power at very large scale, but there's also functions of learning and change at sort of subscales that typically kind of get ignored or don't really pay attention to them. But we all have absorptive and adaptive capacity. All of us endure changes, and some of us endure those changes in different ways in which we can operate at different scales.
Well, I like the example you gave earlier this week, where some of the transitions in fire management is looking at local practices and education to where they actually manage and understand the fire risks at that local level, using state and federal activities to help sort of help support some of those efforts, but that the action is done by local communities. I think that type of scaling and interconnection is really something that for a number of climate change actions is the way forward. Yeah, Melissa.
You say is that one of the big problems are these mandates federal agencies, and, or not so much the mandates, but the idea that we have to follow the mandates all the time. And which really resonated with me because that's what I found in my work is that the officials after Katrina, they were saying, well, we couldn't do anything because that was the mandate, that was the mandate, that was the mandate. But then in Hurricane Sandy, Obama came out and said, I don't want any bureaucratic red tape. So I'm wondering, in terms of like, what do you think in terms of the mandates, are they generally good? We have them, and that just for specific cases, we have to up so that we have adaptive capacity, or do you
I guess I don't have a solid answer, but to me, there seems to be at the federal level, they set, I think if they can set the goals and sort of meaning of a particular law that protects society, I think that's really useful, so that there is sort of an understanding of what we need to do as a society at that level. Implementation, if it gets so prescription and rigid that it precludes common sense action, then that's when there has to be some adjustment. And so that's where I think finding ways of incorporating adaptive management practices would be quite useful.
Yeah, I would just add to that by saying that, I don't think there's one stock answer, but where there are examples where planning and policies have incorporated climate considerations into response mechanisms that are more either event response or seasonal change response focused, is where people have flexibility. But the problem is that so many of our laws and policies were negotiated and made in times before our current climate understanding. So either climate isn't considered at all, or if they talk about weather, which isn't really climate, and they don't account for seasonal change. So like my work that I did in Alaska, that was what I was looking at, is how do they actually make management systems that for in-season responses, so in-season management responses when, say, you have a warmer fall that brings different ecosystem that impacts harvest. So I think that's where the trend is going, is trying to, we use mainstreaming climate change nowadays. Last we talked about how do you actually start to consider our current knowledge of climate as we're redoing our policy. So that's kind of the trend that's happening now.
And for us in the West, where our water laws are so complex and so and they're relatively rigid, and how we actually look at legislation to modify those is one I think where lawyers just kind of they see a lot of business hours involved with that. So I think they're interested. But I think in a way of what we do as a society to actually manage our water in the West, given these restrictions and rules, it's going to be quite daunting.
Looking at this slide, I like the last one. And in my mind, I wonder whether what we're really talking about is those early provisions of sort of new, nimble, resilient, and adaptive existence programs. Looking at the future changes in climate politics and all of these other things. But I challenge that word equilibrium. That it seems like we've come past that to incorporate change and flexibility as opposed to trying to find that state of effort.
I totally agree, and I won't defend them. I mean, I could.
They're also governors, so how do you call it?
So, I mean, I guess I
I'm not
can
argue with them either, but,
modify this, but.
I think they've also, I mean, Western Governors have done a lot of work since 2006. I think their verbiage and their more recent documents probably doesn't say equilibrium anymore. I would be willing to bet.
Last word, Tony.
Just a quick comment, law, policy, bureaucracy are all engineered to provide stability, certainty, predictability, and accountability. And all of those run very counter to adaptability, flexibility, nimbleness. So these are not just sort of functions of archaic ideas. The law serves a very vital purpose in social organization. So, there's some fundamental tensions that between sort of ecological resilience like this and how we organize society. It is actually not that far-fetched that a governor can say equilibrium.
Good point. Sure, why not?
Thinking about
Well, we've seen failure from the federal system down. Huge gridlock that's in place the last decade or more. So, in essence, building it from the ground up and sort of building a more knowledgeable and responsive set of communities that can influence the federal system, I think is necessary. So, I'm not for dismantling the federal government. I think it's really necessary for a number of reasons. But, however, I think we need the public to be more informed of how to take responsibility and action, and by doing that they can provide guidance to the federal system and state systems to provide those services in appropriate ways. So I think it will take some of the bottom-up community development and outreach to make that happen. One of the reasons why I'm really excited about working with the Climate Science Center is that's an opportunity to really start working back at that community level from a climate science perspective or ecosystem science academic perspective. We've been so hard working at how we understand climate change, but not working with communities about how to look at solutions, how to deal with that. And so by working at that one level of just looking at basic understanding, we really weren't providing information to society as a whole that they can utilize and actually change the political debate or discussion on climate change issues. So I think those type of efforts are really important. So, thanks.